So the main factor that controls how much water the kidney excretes is ADH. And now let's talk about how it works. So the part of the kidney that ADH acts on is here. It's the collecting duct. So let's zoom in on a little piece of the collecting duct. So here's a zoomed in version of the collecting duct. And what ADH does is it comes over, and we'll draw it as these little circles, and it binds to receptors on the principal cells in the collecting duct. So not the intercalated cells, but the principal cells. And what happens when it binds to these receptors is that it causes the cell to put aquaporins into its apical membrane. So these are aquaporins, and if you recall, aquaporins are channels that allow water to pass freely. And so these aquaporins allow water from this fluid, which is basically urine at this point, they allow water to pass through and therefore get reabsorbed. So water molecules pass that way. And now hopefully this leaves you with a lot of questions. If I stop the video now, you should be really unsatisfied. And there are a couple of reasons why. One is, okay, so you put aquaporins in the apical membrane, but how is water getting through the basolateral membrane? Well, it turns out that the basolateral membrane actually always has little aquaporins in it, so that it's really easy for water to pass through that side. So that's one complaint you might have. The next complaint you might have is that when we talked about fluid shifts, we said that water shifts in and out of cells through aquaporins. So that made it seem like cells always have aquaporins and water can always get into them. And that's true to an extent, but the number of aquaporins is limited so that that can't actually happen so fast. So when we add more aquaporins into the membrane, it allows a lot more water to get through and faster so that you can reabsorb more. So that might be complaint number 2. And now complaint number 3 you should have, probably the biggest complaint you should have is, we spent so much time talking about in the proximal convoluted tubule and the loop of Henle and so on. We spent so much time talking about what drives the reabsorption of sodium and water and so on. We talked about all those osmotic forces that cause that to happen. So what is the force driving water to cross here? The aquaporins allow water to pass through, but what causes water to go this way? And the answer to that is that actually out here we have an extremely high concentration of solutes. So what is out here? Well, out here is interstitium, right? We're not inside cells and we're not inside the blood, so it's interstitium. And we're actually in the part of the kidney that we call the medulla. And so I'm drawing this dotted line to show the separation between the cortex and the medulla. And so the high concentration is here in the medulla. So it's in the medullary, meaning in the medulla, the medullary interstitium. So that's where we have our high concentration. And because we have a very high concentration out here, the driving force for water to be absorbed is our usual driving force, which is osmotic. Now this just brings up more questions like, how do we have a high concentration of solutes here in the medulla? And that'll be the subject of upcoming videos. But for now, just understand that the driving force for water reabsorption is this high concentration, and the high concentration is always here, but it's only when you have ADH, which comes along and which puts aquaporins here in the apical membrane, it's only then that you're actually using this high concentration to drive reabsorption of water. If you don't have ADH, you don't have the aquaporins, and therefore you can't make use of that osmotic difference.